All right, good afternoon, everyone. Welcome. So I have our next session ready to go. I have Gal Elbaz ready, and I will let him take it away.
Thank you very much. Hi, everyone. Thank you for attending this talk, 0000 Day, exploiting private network through the browser. And let's begin. So quickly about me, I'm Gal. I'm the co-founder and CTO of Oligo Security. Been more than a decade in security research, attending exactly those conferences and talks, so really happy to be here. Been starting my career at Checkpoint and hacking and breaking application for my living, and now also protecting them, but we'll leave that aside. So this is a super interesting story that is actually a rolling story from within the last year, and we're gonna go quickly over the agenda just for us to understand what we're gonna see today. First of all, we're gonna talk about the concept of client port scanning. And how it actually led to the PNA, the private network access. From now on, I'll use that as the PNA. And we get into the internals of the 0000 day and how this magic actually applies and how the past tryouts in history was not cutting to it. And of course, like any good talk, we need to RCE something. So we're going to demonstrate how we're going to chain this attack with a famous application in order to demonstrate how it can be used in order to attack private applications that today are considered safe. And of course, deep dive into how the different browsers dealt with the responsible disclosure and how the fixes apply. So without further ado, let's start. So how many of you here have heard about client port scanning? And I'm not talking about scanning the internet, I'm talking about scanning your own, see not a lot of faces, but I guess you'll be surprised that probably all of you has been port scanned before. Who remember this weird, I think it was Reddit or something that someone says, hey, why is this website port scanning me? And later on, we found out it wasn't a script kiddie. It was literally eBay that port scanned their visitors. It was a huge thing back then. And what they basically did, we don't know if it was for monetization or fingerprinting or security, but basically what you see in front of you is that they leverage the fact that they can just communicate with localhost and start scanning all of their visitors' local machine in order to identify who are they by scanning their ports, identifying which applications running on this host. So this made a lot of buzz. And this is exactly what PNA tries to solve. And this illustration from now on will help us to distinguish between what is considered the public network, the top-level domain, the .com. This is especially from the PNA website, which is one of the initiatives made by Google. And you can see how they distinguish between what is the public network versus, your home or office network, which is considered private, and of course, you as the local device running within those networks. So there are many ways to run servers, right? From the basic 000 that just binds on whole interfaces to the local host, of course, that can serve as the 127.0.0.1 or just the string localhost itself. And we're going to talk about those two specifically. And this story actually begins it's been 19 years old already, bug. And it started with this lack of standard between the browsers themselves. And each and every one implemented their own security mechanism. I know it will make everyone in this room feel old, but we're talking about the early days of the internet. HTTPS wasn't exist by then. And there was a really weird issue opened on Mozilla Firefox that said, hey, I think a website are trying to attack my router. And like, it was a weird thing, but it grew a lot more. And he said, hey, it's literally trying to attack my home network. I think it's for like scanning internal stuff or fingerprinting. We should all pay attention to those stuff. It's not part of the RFC, and like something should be done. And of course, it was too late when he already said, hey, now it's literally an active campaign. Again, we're talking about, as you can see, 19 years old ago, but it was a great article by Symantec, which called drive-by farming. And you can see it was simply that. It was that easy just to make your home or router or office router to bind and do this DNS rebinding attack to another address. And basically, this attack went too successful. There were more than 300 home routers and office routers that were compromised. And again, back then, I know we were thinking self-certificate or HTTPS, but again, back then, those stuff did not exist, and this is why this attack actually went really successful. And this actually led to start thinking about this problem and trying to solve it. And this is where the great initiative by the Mozilla Firefox guys started to map what is considered a much more private address. You can see the addresses in front of you, and the sharp ones out of you can notice that something is actually missing, but we'll talk about it in a second. And of course, it wasn't a bug, it was a feature, it was an enhancement. It's only 300,000 routers has been compromised, right? So this new enhancement basically suggested in order to block from a website getting access to local private IPs. And of course, the 000 itself was missed, but they actually also notified that and decided to add the 000 address as well. And you can see that in the end, they really compiled the list of what is considered as private. And we'll talk about those initiatives, but this has started 18 years ago, and still it's open and not fixed up until today. And then, almost 8 years ago, Google stepped in and started creating what we all know today as the PNA, but it was due to another cool hacking tricks happening in the internet. Probably all heard about CSRF attacks, and which led to the invention of CORS and the ability to restrict from the internet to the internet. So this is the early days of Google trying to solve those problems, and this is where they started working on this initiative. You can see that back then it was still a community edition, so was it a real standard that other browsers may use, but they started working on something much more global than just fixing their own problems. And of course, it always leads to this fun game of hot potato and throwing responsibility from one another, because then Firefox said, oh, cool, so now there's a standard to wait, so let's wait for the standard to happen. We don't want to fix stuff or change stuff, and then the standard will be changed. So we will wait, and we're not going to fix those issues until private network access will be applied. So what is this private network access that we're talking about? What is basically allowed or disallowed? And this has started with Chromium that pioneered this and started rolling it out. And again, as I mentioned, the aim back then was to protect from cross-site request forgery, CSRF attacks, but also, again, mentioning the same problems we talked about, like targeting routers and other devices on the private network. And they literally admit that this attack affected hundreds of thousands of users. So that was the goal of starting creating this standard. And they even had an open issue for the 0000, and I guess we all think good. It didn't went undetected, but those stuff just sounds good. And when you start actually rolling out, it wasn't that easy. They broke a lot of the internet and a lot of websites, and that's why they decided to roll back and start to do it much more gradually. And when they started rolling it back, they saw that, again, in defiance of the spec, but it seem pretty common, so they decided to allow the 0000, because I guess vendors or users has been using this weird address. We'll see why and how it should be used, but this led to the fact that a lot of the PNA stuff that we saw are blocked today in all modern browsers, besides this 0000. And why and what is this weird address? Okay, let's talk about it. If you just Wikipedia that, you'll see that this address have multiple uses. What does that mean, right? And when you deep dive into it, like 0000 basically means, again, from the RFC, this host on this network. And basically, it is actually a part of a legitimate use in the DHCP handshake in the discovery before your endpoint actually gets an IP assigned to it. It uses the 0000 as is address to begin with, but again, if you can see the RFC and like really written in red, this IP address should never be used as a destination address. And this is where interesting stuff started popping out, and Google decided to create a counter and see how many websites around the world actually use this weird IP address. And you can see that back then it was like 0.002%, but of course it grew out immensely. We're talking about more than 10x growing only in like I think a couple of years. And let's say that I cannot fully, again, share the whole comments, but they mentioned that they seem that most of them are malicious websites, and there wasn't really a real usage of using that beside attacking someone. So with this huge increase, we thought that there's a lot of discussion around it, and actually something really, really cool here. You can see there's another, like, you can see how it's going down from actually fixing it after we disclosed all of that, but then there was a spike up a little bit after our DEF CON talk, so I guess attackers do listen to DEF CON talks. And what was really intriguing in all of that is that when you just think about it, it's that simple and stupid, but what you'll see on the left side, like everything that the PNA should block, right? It's those like localhost or like those addresses and everything that is considered private. By design, when you just communicate or you just send a packet to 0000 on your host, basically logically you're bypassing all of that because this address does not exist. And when you reach out to this address, basically just redirects it to the entire network interfaces running on this host. So it means by design, the thing that we're thinking that we are blocking for the past 19 years are actually not blocked and are all enabled through the same simple address. All you need to do is just change the destination address instead of localhost, put 0000, and all of those attacks are revived again. So when we say everything, we mean everything HTTP based. So I guess there are developers in the audience in here, right? We do, again, by design, we are developers, we are lazy, right? So we want to do stuff quick and efficient and just connect to the source. So a lot of us, I guess, are working with port forwarding directly with your Kubernetes or your IDEs or everything that will just help you to kickstart fast. So those one are, I think, a big target of those stuff, the developers themselves. I think there's a huge movement, regardless, in the world about attacking developers. When we started moving to the cloud, the developers themselves started holding most of the credentials to the cloud or credentials to the environment, and that's why they became a big target. So it was really interesting for us to also scatter this. Of course, operating system services. We're talking about AirPlay or CAPS or anything running within your local device, and of course internal network access like VPN or anything that binds to your local addresses, like again DNS rebinding attacks. So we decided to test this, and we built a simple port scanner. We built it in WebAssembly just because it's cool. There's no reason for that. It's the same JavaScript API in the browser that you can see, but what we basically done, and by the way, all of you can just go to the GitHub page and download this port scanner and port scan yourself and see how it works. But what we basically have done is the ability to map which ports are opening are open and listening on each and every host, and it was pretty simple. You can see the Wireshark snippet from here, and you can see that when we're scanning for the ports, if we're getting a connection refused, it means this port does not exist. But if we get some sort of an error code, it means it does, right? So we're starting to map all of the internal ports of our own computers, right? And then it really intrigued us, like what is possible to do with that, right? So from this classical DNS rebinding, like if you'll try to do it on your local host, you'll see it's gonna get blocked. But suddenly, when you do it on the 0000, it works. So a lot of the fundamental stuff that we thought we knew, or again, we thought that are already, gone from the world, sadly are not. And this is where I think we decided to start chaining it with something big that we found and done. So the shadow ray story, it's actually the incentive and the whole motivation for the 0000. This is the first ever attack campaign in history attacking AI workloads. Our team found this campaign and disclosed it. We're talking about a campaign that started for more than a year and went undetected for almost a year. This is basically the only existing example of a real attack on AI infrastructure. We're talking about from Google, they're doing lectures about safe or unsafe implementation of Kubernetes to organization like MITRE, which started mapping techniques and attacking AI infrastructure. This is the only existing example of an AI attack. And again, let's start with the beginning. We are fans of Ray. We use it ourselves. This is an amazing framework made by the Anyscale guys. Basically, it's just Kubernetes for AI. Okay, it allows you to orchestrate your jobs and do it in a proper manner. You can see this is de facto the ruling framework. A lot of the biggest companies in the world uses Ray, and of course you cannot dismiss that. But GPT 3.5 was trained on Ray. So you can understand how industry standard this tool is. And of course, like any other AI framework that's been done by data engineers, it's in Python. And of course, there was a lot of good intentions by the maintainers, but something that we saw along the lines was really intriguing for us. It all started with 5 new vulnerabilities that were disclosed to the maintainers of Ray, the amazing Anyscale people. And of course, we cannot, I'm wearing my other hat, and of course they have their own reasons, and they are the maintainers. They can do whatever they want. They maintain the code, but they decided to dismiss and dispute 5 vulnerabilities. Specifically, this one was an RCE that is, again, according to them, the intended behavior, right? You can understand this is like the intention of Ray to run jobs. But as a security expert, when you see that you can literally run arbitrary commands without being authenticated, and anyone from the network can do it, your spidey senses started to tingle and say, whoa, like it's not the intended behavior. Like I'm sure those guys didn't meant to allow the world to RCE their clusters in that easy way. And you can see like the vendors claim, of course, like this is the intended behavior. Users should run it inside a controlled network. Again, like every other framework that tries to put the responsibility on the users. Users are not security experts. Data engineers are even far more, left from developers that might even have this a little bit of security perspective. But as you can see, the maintainer position is that running jobs remotely is an intended behavior of the package. Cool, so you're telling me this is basically not a bug, but a feature. Okay, so we decided to look around, and of course it all starts from that essence that we want users to adopt those tools fast, so we just want to give them the fastest, easier way to just one click and start using Ray. And as part of it, you can see that by design, it's run and listening and binds to the 0000 to accept all incoming connections. And this, of course, very risky behavior ended up being a real attack campaign that we saw only by ourselves. Thousands of clusters. Just imagine each and every IP has a whole cluster behind of it. Each and every machine, it's these pricey GPUs that, again, attackers were right about attacking this compute power, which is so strong and so expensive, and this is why it went so successful. So again, we are talking about AI workloads, right? So a lot of those AI production workloads holds a lot of the secrets and the credentials to other environments, or for example, database credentials like Postgres, or even SSH keys that were on the machine. Everything we're showing you, it's actually an attack that we saw. And how? Because basically Ray, luckily for us and for everyone, is keeping an history list of each and every command that is running on Ray. So we could actually extract the commands that the attackers did, and from that start to follow their tracks. We found 62 OpenAI tokens, and we disclosed all of them. We got zero bounty, even though they say they're bringing bounty. So I don't know, you should check that. Hugging Face token, it wasn't that Hugging Face when we told them. There were a lot that had been compromised. And of course, the supply chain angle is always risky when we're talking about those stuff. Slack token, I don't need to explain to this room what it means to breach private communication channels in big organization. And of course, Stripe, we could literally take money, and this is how crazy it was. And again, everything I'm showing you was all open to the public. Any one of you in this room could send one packet and run code and do whatever he wants on this huge environment. And of course, it is by design running in the cloud, so AWS keys and everything that would allow attacker to laterally move. This is what we found and how it looked like from our angle. You can see the wgets and the command and the reversal that has been triggered. Some of them were, in a very stealthy way, encrypting everything. Some of them were just, bluntly doing the reverse shell and starting to move inside. The crazy thing, I think, to us was like, whoa, there are at least 6 or 7 different crypto miners on each and every machine. We're like, wow, we didn't know about this attack. The world didn't know about this attack, but attackers knew about each other, right? And it was kind of funny because there was kind of war games. If you all the nerd of you remember it from the old assembly days when you're writing your own script to kill the others. So each and every one of them, and I think the number one who won just elevated its privileges, looked in memory for other crypto miners, killed them in order to take down the entire resource of this specific machine. And I think the number one attacker here was 4th worldwide in the crypto mining pool. So it was successful. And of course, it was hitting waves all over. It was published over Forbes and a lot of other great places. And this is where we were pretty shocked to see the comments, both from the security leaders we were talking to, but also from the industry itself, saying, wow, it's insane, what the heck? And yeah, but it's behind the firewall in a WAF, so like it's all good, like we're protected. And when we hear those stuff, we're like, wait, what about lateral movement? What about like, it's so easy to just get one leg in a network and then laterally move. So like, this is where like this whole idea and the whole motivation of like, again, instead of just trying to educate, just show, I think it's the best way to educate. And this is where I decided, hey, like we know, we've been those attackers, we've been in the other side. We know it's a lot easier to find a way, one way to get in than trying to protect. So hey, let's come up with a new way that will allow us to again change the mindset of the industry about whether an application is actually safe or considered safe if it's behind a firewall and a WAF. And this really led to this teeth that you see in front of you. Can we actually use the browser in order to attack private internal applications? In the end, the browser serves a leg within your network, right? You're surfing and using it inside your private organization, helping it to map actually each and every URL that you ever used to the World Wide Web. It's another issue for itself, but all we needed to do, and this was intriguing for us, is just to dispatch one packet, and we can completely take over those apps. And again, Ray or Shadow Ray was only one example. What we wanted to convey and show that it can happen on so many different types. But when we took a real example of a real attack, I think it showed people that it is real. So in order to demonstrate the whole attack flow, we started with not so good phishing email, right? I guess LLM today would help me a lot more, but the whole concept was not about doing a cool email phishing campaign, and the whole aspect was to show the simple example that we wanted to convey, which is someone uses Ray, a developer, either on his localhost private machine or just using port forwarding, and then only by clicking or just accessing the website, what will happen is that our malicious JavaScript will just use this one HTTP post request in order to compromise the cluster. And in order to do that, all we need to do is just use the 0000 as the target IP address. And I know all of you might think, hey, it's a link, you need to click something. So again, just let's be honest, today it's not that hard to make someone surf to your website. You can infect people with ads. You can do a lot more tricky stuff that you think than, again, just writing a really cool phishing email with GPT. But this is how it actually looked like behind the scenes. You can see that our script basically running with the mode no course, and all he does is basically just sending this post packet to, again, this is the port that Ray is listening on by design, the 8265. And what actually happens is that we do that. Actually, this serves as the same script you used earlier, so you can try to RCE yourself. And this is how it looked like. You can see on the left that there is like a red job that indicates that the request has been blocked, right? Course protection actually works, but you can see the status code is 200 OK because we don't care about the request. All we care is about just dispatching this one packet to the private network, and it allowed us to completely take over the entire cluster. So it seems like a course error, but on the second request, hey, it reaches the server. We started with just like dumping the credential and say, hey, echo exploited, it works. But again, this is just one example, and we of course weaponize it to a full RCE and how we can run a reverse shell. And you can see how it looks like from the different angle from the Ray dashboard. You can see that each and every time that we're just surfing to this website, it would just initiate the attack again and again, and you can see how many times it echo exploited. So in order to chain everything together, what we basically done here is just to demonstrate how we have an attacker, which is presented on the internet, is not connected to the private network. On the local side, we're gonna run Ray like any other developer, ray.init. This is how developers usually run it, super easy and fast. And then you're gonna see, we're gonna open the dashboard, which binds to localhost, and now we can use Ray. And on the other side, we're gonna open the jobs just for you to see how our malicious job will be documented. On the other side, again, not such a good phishing email, but again, this is not the point of the talk. You can see how we're listening on the attacker's angle, and only by clicking, again, we're attacking ourselves, right? On that, you can see how we literally run reverse shell. So now is the time to do some applause for exploits. I know it's a video, yeah, but we are a little bit afraid of the demo gods, but we urge you to go and check for yourself. Everything we did is open sourced, just again, for sake of education. And it made a lot of buzz around the world. We don't know if it's just this, again, simple, weird IP that everyone was intrigued in, or just the fact that the attacks graph was getting, or the malicious website in the world, as we saw only from the DEF CON talk another additional 100,000 website that got added to the counter of the 000 website. And now we're getting to the interesting part of how the industry has dealt with it. So, of course, it worked on all of the browsers, and I know usually in those conferences we're really used to bashing Microsoft, but actually here Microsoft did an amazing job, and Microsoft is blocking this address on the OS level, which means it doesn't even connect to the browser, and which means on that angle, it will not work on Microsoft. So everything we're doing is just for Linux and Mac. And of course, we're showing from Safari, Firefox, and Chrome how this exploit works. And first of all was Safari and Apple that actually did an amazing job fixing that. They literally added another if statement to each and every HTTP packet on the globe. So I'm not proud of it. I don't know, adding another packet to each and another if statement to each and every packet, but you can see that it just checks if it contains only zeros and block it by design. So it was been done on the WebKit level. This is the engine that serves Safari. So actually, Apple did an amazing job and were the one that actually fixed this issue. Chromium, which are the pioneers of the PNA, actually are the one that we did a disclosure with, and they have been amazing in helping us and helping them. And they did started working on new features to PNA. You can see our report and how they did mention all of the stuff that we just discussed, that this, of course, address can be used in order to bypass most of the PNA protection as we know it. This, again, can also be abused, as we mentioned, in reviving DNS rebinding attack, or not reviving. I guess they're working for 20 years and we just didn't know. And, of course, the ability to attack application through the localhost. Of course, it also serves as a way for them to measure those stuff. So from the ability to see how there is a growing number of websites that are maliciously using it, and they're, in their own words, those malwares leveraging this attack to specifically attack developers, as we mentioned. I don't know if it was only our example or the fact that they know something that we don't. But they did a great job on trying to work it through. But when they, and I think they disclosed that and fixed it, and they even gave us a bounty, but it was breaking a lot of websites again, so they rolled it back. So right now it's not protected over Chrome. And of course, Mozilla, they are an open source, and they are still waiting for PNA to be a standard. And this is why, again, I think the biggest thing that we made here is to finally make those browsers maintainers talk to each other, not from tickets. And this is where they understood they need to solve it in a deeper level. So in order to do that, they went down, and I think this was a Mozilla idea, and I think it's what will actually solve this problem in the end, but go down to the fetch level. Fetch is basically the standard in the internet of how HTTP works. So by going down to this level and changing it on the fetch level, all of the browsers have to use that, and in order for them to support the fetch in a proper way, and by that block the 0000 on the fetch level, meaning it could not even dispatch this type of packet. And when we're talking about the future of PNA or the protection of those browsers, so the work that now is being done in the industry is to head those PNA HTTP headers to open source projects. And also what we just showed, the 000 will be blocked in all browsers in the fetch level, as we demonstrated, like we hope, right? They started working on it, but it didn't really fully rolled out. And of course, our, I think, main agenda for this talk is that you should secure your local host. And local doesn't mean safe. And even though we have this false sense of safety that applications are protected behind the firewall or WAF, our main recommendation is that, hey, don't trust those stuff. Add authentication or authorization or any type of mechanism that can add another step of mitigation to your apps. I think even a great example is Jupyter. Jupyter Notebooks, I think they even just print to the screen like a generated token that you can either use and not even going all the way to implement CORS or add authentication in the right manner. We do, again, recommend to add all of those layers on each and every web app you're running internally. And of course, just to finish with a cool bonus thing, I don't know if anyone in here knows all of this internet scanner, port scanner on the internet, which you can just put an IP address and just scan the internet. And you can see from your left that when we're trying to use the localhost 127.0.0.1, you can see it says invalid domain, invalid IP, it cannot use it. But if you use 0000, you actually make the port scanner port scan themselves, and you can see how all of the open ports on the machine that literally does that is working. So I think this is the best testament of how this thing went undetected for years. So we're coming to the conclusion, and we have a couple of minutes again also for Q&A, and I'm right on time, as I can see. But I just wanted to mention that that was just one example. This is just the tip of the iceberg when we're talking about those attacks. Stuff like certificate transparency. I don't know if you know, but your browser actually maps your entire private infrastructure. You can actually go, and we all in the West world are using Google as our trusted authority for certificate, but if you just go and look for your own company domain, and you'll probably start to see a lot of subdomains that have been mapped around the world. And again, this really helps attackers to redirect their attacks to a specific subdomain that might say, hey, this is the Ray cluster, and it will allow attackers like us to do it in a lot easier way. Plus, Ray was only one example. We actually proved and show different various type of applications, from Seleniums to IDEs to even really lately MCP servers. They're all listening and using 0000 as the way to bind. So of course we disclosed and notified all of it, but I think it's also a call to action to the community to raise awareness, to start thinking about those stuff when you are running stuff locally or just running services listening on your host. Don't expect them to actually stay local or stay safe. So without further ado, thank you very much for attending this talk. It is a true pleasure to be here in BSides. If you have any questions afterwards, you can look at me at X, Twitter, whatever Ilan will call it tomorrow morning, and I would be very happy to answer anything. So thank you very much.
All right, thanks everyone.